am from first BTech second semester. This is CA2 Assaignment. Today topic is implementation of stack using array with example. The subject name is data structures. The subject code is 23CSC201. My name is M. Dhanush. My roll number is 244G1A0580. I am from computer science engineering. Okay, the implementation of stack using arrays with example. First, characteristics of queue. Queue maintain the order of elements as they are added and removed. They can be implemented using arrays or linked lists. The size of queue can be fixed or dynamic or depending on the implementation. Now the introduction to queues. A queue is a linear data structure that follows the first in first out FIFO principle. The elements are added to the rear and removed from the front of the D queue. Queues are commonly used in various applications including scheduling and buffering. Array representation of queue. An array based uses as a fixed size array to store elements. 2 points are typically used, one for the front and one for the rear of the queue. This presentation simplifies the management of queues operation. Now the queue operations. There are various queue operations. There are the primary operations of a queue or NQ, insert, and DQ, remove. NQ adds an element to the rear of the queue, while DQ removes it from the front. Additionally, we can check if the queue is empty or full, which is important for managing the queue. Now, NQ operation. The NQ operation involves placing an element at the rear of the queue. We first check if the queue is full to avoid overflow. If not full, we add the element and increment the rear pointer accordingly. Now DQ operation. The DQ operation involves removing an element from the front of the queue. We must check if the queue is empty to avoid underflow. If not empty, we retire the front element and increment the front pointer. Now example of queue implementation. Consider an array of size 5 to represent our queue. We will perform a series of NQ and DQ performance on this array. Initially state front is equal to 0, rear is equal to -1, Q is equal to dash. Now step by step example. NQ10, Q becomes 10, front is equal to 0, rear is equal to 0. NQ20, Q becomes 10, 20, front is equal to 0, rear is equal to 1. DQ, front element is 10 removed. Q now is 20, front is equal to 1, rear is equal to 1. Handling overflow and underflow. Overflow occurs when we attempt to NQ an element into a full queue. Underflow occurs when attempt to DQ an element from an empty queue. Proper checks must be implemented to handle these scenarios effectively. Now last one but one least, conclusion. Implementing a queue using an array is straightforward and efficient for fixed size queues. Understanding the basic operations and their implementations is essential for effective data management. Queues plays a crucial role in various operations and applications, making them an important data structure to learn. Feel free, this structure of a guide is presentation for you. Okay, thank you.